I've really dealt with all of my domain restrictions. I'm now kind of looking for my horizontal or slant asymptotes. Initially, the degree of my numerator was 4 and the degree of my denominator was 3. So n was bigger than m, and that's either going to have no asymptote or a slant asymptote. We did some simplifying, and I got this simplified equation. The only thing that canceled out was x, so I could rewrite this simplified equation as x cubed minus 5x squared minus x plus 5 divided by x squared minus 2x minus 8. This is another way of writing my simplified equation, and the degree of the numerator is 3, the degree of the denominator is 2. So again, we're in this situation, so we will have no asymptote or a slant asymptote. When we have the numerator a higher degree than the denominator, we need to simplify this equation by factoring long or synthetic division. I already factored to simplify as much as I could, so now I need to use long or synthetic division. In this case, my denominator is not set up to do synthetic division, so I'm going to need to do long division. So I'm going to start that by writing out my numerator, x cubed minus 5x squared minus x plus 5, divided by my denominator, which is x squared minus 2x minus 8. To start, I'm only really looking at that first term to decide what I need to multiply by. So I'm looking at x squared. What do I need to multiply x squared by to make it into x cubed? And that is x. So then I'm going to take x and multiply this whole expression by x. So that gives me x cubed minus 2x squared minus 8x. And then I will subtract. My x cubes go away. This becomes negative 5x squared plus 2x squared, so that's negative 3x squared. Negative 8x plus, or negative x plus 8x is going to give me plus 7x plus 5. I'm again looking at this x squared. What do I need to multiply it by to get the negative 3x squared? And that is minus 3. So minus 3x squared, I take that and multiply it through, plus 6x plus 24. And I'm going to subtract. That's going to go away. 7x minus 6x is x. 5 minus 24 is negative 19. So this is my remainder. So that means I can write my simplified equation as y is equal to this piece up here, x minus 3, plus the remainder, x minus 19, divided by my divisor, x squared minus 2x minus 8. This is my simplified equation. Or x minus 19 is my c of x squared minus 2x minus 8 is my d of x, and x minus 3 is my e of x. Why do I care about that? Well, the degree of the numerator is smaller than the degree of the denominator. So that means that this piece here is going to approach 0 when x gets really, really big or really, really small. This quantity in the denominator is getting big, much bigger than the top, so this goes to 0. So as x gets really big, y is just going to approach this, whatever's left here, and that's an equation. So this piece here becomes my slant asymptote, or this becomes my slant asymptote. Okay, so y is equal to x minus 3 will be my slant asymptote. Because I have a slant asymptote, there is no horizontal asymptote. So now I need to graph y is equal to x minus 3. So that's going to be there and there. And I'm going to graph it with a dashed line. So this is the line y is equal to x minus 3. That is my slant asymptote. I need to find my x and y intercepts. I find my x intercepts by setting my numerator of my original problem equal to 0. And when I do that, I get x is equal to 0, but I know that's a problem because that's not in the domain. So I'm going to get these three values are equal to 0. So setting my numerator equal to 0. So that's a of x is equal to 0. So that's going to give me the points negative 1, 0, 1, 0, and 5, 0. And I got those by setting each of these equal to 0 for my x-intercepts. My y-intercepts I get by plugging in 0. I actually do not have a y-intercept because when I plug in 0, so this is when x is equal to 0, I get 0 over 0, which is undefined, but I already know that I have a hole at the point 0, negative 5/8. So I'm actually going to graph that 0, negative 5/8 as a hole. That's an open circle at 0, negative 5/8. I'm also going to graph negative 1, 0, 1, 0, and 5, 0. Okay, so I've got my three regions of my graph here. X is equal to negative 2, and x is equal to 4. I know that I have the point 0, negative 5/8 that is a hole. You want to call out that you have a hole. I like to do an open circle next to it, and I like to box it and write the word hole. I really like to make sure that I know that that is a hole, that there's a missing point there. I know I have the point negative 1, 0, and I know I have the point 1, 0. So I technically have enough points, but I don't really feel confident. I want to have another point close to this axis, to this intercept, so I'm going to plug in 3. I'm going to go to my calculator, input the equation into y1, make sure my table is set to ask, and then I'm going to input values. I'm just going to check negative 1 and 1. They're both 0. I'm also going to check 0. I should have an error, which I do. And then I'm going to plug in 3. So when I plug in 3, I get 3.2. So I'll graph that. 3, 1, 2, 3.2 is going to be about there. So what I can see is my graph seems like it's approaching this vertical asymptote and this vertical asymptote. So I'm just going to graph that. So we're going like that and like that. So I'm kind of up here in the middle. If I go to the right, I'm going to go with points 4.5, 5, and 6. So in my calculator, 4.5 is going to give me negative 2.962. 5 is going to give me 0. I already knew that. And then 6 is going to give me 2.1875. So let's see if that's enough points. 4.5, 1, 2, just less than 3, 5, 0, and 6, 2.1875. This is enough. What I see here is that my graph is approaching this dashed line there and this dashed line there. Then if I move on to the other side, if I maybe go with negative 2.5, negative 3, and negative 4, let's see if that's enough. Negative 2.5, negative 3, negative 4. So negative 2.5 is negative 12.12, about. Negative 3 is about negative 9.143, and negative 4 is about negative 8.438. So I'm going to graph those on here. Negative 2.5, negative 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So just a little past that right there. Negative 3, negative 9, 11, 10, 9, so about here. Negative 4 is going to be 8.4, so that'll be about there. And it kind of looks like I'm approaching this, but I think I want another point to the left. Now, I don't know if -5 will do it, so let's go with -6 just to be safe. So -6 is going to give me -9.625. So 9.625 will be about there, and that's going to be over here. So now you can really see that this graph is approaching this asymptote here, curving and approaching that asymptote over there. So this graph kind of had everything in it. Let's go through our checklist just to make sure. I fully factored my original equation because that's a great first thing to do. I found all my domain restrictions. I simplified by canceling out any factors. I identified my holes and my vertical asymptotes. I checked my horizontal slant asymptote rules and saw that I was going to need to do synthetic or long division. Found my my x and y intercepts. I point plotted and I graphed the curve. What I didn't do is label all of my x and y intercepts on here. I did label my asymptotes, but I need to label these intercepts. So I have an intercept at 5, 0, 1, 0, and -1, 0. And I also have a hole at 0, -5, 8. So you want to make sure that all of those key points are labeled on your graph. My asymptotes are labeled, and I've got my table of values right next to it, so any values can be pulled out if necessary. This is about as hard of a problem as they get. This has everything in there. We have a slant asymptote, we have a hole, we have all kinds of things going on, multiple vertical asymptotes, so this is about as hard as they get.